In this session at GroupBy, John Martin will be talking about using row-level security and dynamic data masking in SQL Server. Take it away, John.
Okay, thank you very much. So let me just find everything here. Come on, make this work. So what we're going to be looking at today is row-level security, dynamic data masking, which were two features that were added with SQL Server 2016 and are in Azure SQL Database as well, but we'll cover that more as we go on. Okay, quick thing about me. So my name is John Martin. I am currently the product manager at SentryOne, managing the SQL Sentry monitoring toolset. So if anyone feedback, get in touch with me, but otherwise we're done. I'm also a Microsoft Data Platform MVP. Overall, been working with SQL Server for a long time. Dev, DBA, BI, and prior to working for Sentry, I used to work for Microsoft as a field engineer based over here in the UK. Contact details are there on the slide, so please feel free to stalk on Twitter, send me emails about SQL Server stuff, read things I blog, or get in touch on LinkedIn. Happy to do that. So I'm going to talk about some of the things that we're going to see on the agenda for this session. So whilst it's quite obvious the title is row-level security and dynamic data masking, one of the key things that we want to have a look at and understand first and foremost is some of the key security principles. If we don't get the key security principles and the fundamentals in place, then no security feature is going to save you bacon. You can add as many as you want afterwards, but as I'm sure you've known in the news today, I don't know if it's gone how widely sort of known it is, but obviously Equifax had a little breach through earlier this year, which they announced today, which is kind of big considering the things they do. Then we'll talk about the features themselves. We'll start talking about row-level security, and we'll start talking about dynamic data masking. Both in the engine, both very interesting features is probably the way to put it, both V1. And make of that what you will, but we'll discuss that as we go through as well. So, starting with security principles. I am a very, very firm believer in security by design. My background is, the industries I've worked in have ranged from payment processing through local and central government organizations, large corporates, all the way down to retailers and things like that as well. And one of the overriding themes there is how do we protect the data, because the data is of value. You can build a system nice and quick. Very, very easy these days just to knock something together with the various technologies that are out there, and then think, screw it, we'll stick it behind a web application firewall, that'll protect us, or we'll just put it over there on that server and we'll restrict who can have access to it, and that will solve all your problems. No, it doesn't. You have to think about all of the security components. You have to think about, okay, how are we going to be accessing this? What's the medium? All that sort of stuff. If you don't understand all of the components that go into building the solution, you can't understand the different layers of security that you're going to need to put in place in order to make sure it's a secure system. If it's not a secure system, then you run at greater risk. Like I say, designing that core security in place is more than just a permission set. It's more than just views and stored procedures. It's basically all the way from where the data's stored all the way through to where someone is consuming it. And if you don't get that right, it's going to hurt. Touch wood, never been involved in a company that's had a breach. So the big thing to understand there as well is, and the mindset that you need to really adopt is when, not if. Okay, something's going to happen at some point in your career. And in order to understand that, and why I say it's a case of when, not if, it's about understanding the different threats that exist and the different risks that exist for your data environments. And that can be the external threats, that can be state actors, it can be criminals looking to try and get that from it, it can be corporate espionage, depending on the types of industry you're in and the type of work that you're doing and the type of data you're managing and the systems you're managing. It can be internal threats as well. So people trying to become employed in order to take information out. How do you detect that sort of exfiltration of information? It can just simply be people, someone's got wind, they're going to get fired, and they start going through and deleting things, drop database, that type of stuff. Just go into the application, delete all the data. It happens. I was sat next to a consultant whose customer once had that problem, and they rang him and said, help, we need to recover. again, it's something to think about. It's not just people doing it for criminal gain or sort of monetary gain. It can people just be sort of, can be vindictive if they're pushed beyond a certain point. But then also internal threats also take into account accidental disclosure. So it could be a DBA on another team that's got access to a server he shouldn't have access to, and then getting that information. It could be the BI developer that has access to an amalgamation of systems that allow you to piece that information together. So the sum of the parts is sort of broken down in such a way that, okay, we'll store personal information here, we'll store financial information here, we'll store sensitive information over there, but one BI platform that pulls it all together then has access to all that information. You can join it all together to give you that full picture. Again, that's, again, thinking about those risks that exist, what's the options there, okay? The accidental disclosure thing is probably the nice end of the spectrum, in all honesty, but understanding those threats, understanding the mindset to have, will help you build more secure systems, okay? Now, when it comes to security principles, security is basically like Swiss cheese. There's holes in every solution. There's no one piece of software, one hardware appliance, one virtual appliance, one company out there that will protect you completely. Anyone who turns up in a shiny suit and says otherwise is lying. There's no two ways about it. Okay, it's all about understanding where the gaps are in the different technology layers and then coming up with solutions that complement one another in order to try and resolve those issues, which is why it's like making a sandwich. Essentially, you get your bread, you put your piece of cheese on it, and it's like, oh, yay, cheese, but I can still see bread. I need more cheese. So you take it, you get it, another piece, you turn it through 90 degrees, put it down. Oh, still see bread. Clearly, I need more cheese. Pick it up, another slice, in we go. So 4 or 5 slices later, you've got a nice big cheese sandwich, whether or not you're going to put anything else on there, all good. But you don't want to be able to see that bread. That's the way to do it, really. You want to eliminate those gaps. And that's why I say when you understand what the threats are, you understand the end-to-end solution, you understand the security options that exist for all of those technologies and how you can build them together to complement one another so that one security solution will fill the gaps that exist in another one potentially, or a configuration, things like that. That's where you end up with secure systems, okay? So those are the sort of fundamental security principles we need to understand. Once we've got that to hand, we understand that, that's when we can start looking at technology features like RowLevel Security, dynamic data masking, okay? Don't believe the marketing hype. They're not, one of these will not fix all your problems, and the other one, again, will not fix all of these problems for you. Maybe using them together in combination with other technologies, you'll end up with a solution that works for you if it's appropriate for the system you're building, okay? So then we move on and we start thinking about RowLevel Security itself, okay? We're going to start here with this one. Now, RowLevel Security at its most basic level is about restricting who can gain access to specific data rows, okay? Nice and easy, we say. That's what where clauses are for, and we'll hide things behind. Yeah, you can get away with that. RowLevel Security here is built into the engine for a change. Historically, it's been a case of needing to roll your own. Okay, there's various different mechanisms that I've seen systems using. So prior to SQL Server 2016 and Azure SQL Database, where it was introduced, it can be views, for example, which if you've ever used Dynamics CRM, you'll understand some of the pitfalls of that when it comes to really scaling for performance on that side of things. When you've got a lot of data, nested views over nested views over nested views, which is one of the implementation mechanisms, falls flat on its backside. Not great. You can use functions and things like that. We'll discuss those in a bit more as we go through. Like I said, it's SQL Server 2016 and above, and Azure SQL Database. So those are where they stand at the moment. And it's a good implementation, simply because you have to do a lot of the work, which means you've got a lot more control over it. It's nearly there. There's still some gaps in it, okay? And we'll think about some of those as we move through the slide deck in a moment. We'll think about some of the options we have. But fundamentally, the key element here is that the engine is helping you to build a more secure solution. It's not a case of it's not a tick box, you turn it on. You've actually got to do a lot of work for this one, okay? Now, RowLevel Security is essentially designed in, okay? Now, in order to look at doing this, you've got to basically write the function that's going to classify the data that you feed into it as to whether or not it's going to be applicable. Okay, now what that means is obviously we're going to be writing a function that's going to be running quite often. If that function has any inefficiencies in it, then that's going to materialize in your query performance. So for anyone who's used Resource Governor, you'll know the importance of making sure that you've got a very, very efficient classifier function because it hits every connection that comes in. Similar sort of fundamental principle when it comes to the function that you use when it comes to writing and securing using RowLevel Security. It's going to basically run for every query that hits the table. So if your function has a 3-second query response time and your querying the table takes half a second, then it's going to be 3.5 seconds aggregated because that overhead's going to come from your function. Very, very important to make that as efficient as possible. Okay. Now, because it's designed in such a way and we're feeding data into a function, it comes down to understanding your data model, and you've got to do data modeling correct in order to really leverage this function and this capability. What we need to look at and understand is, okay, well, what data are we looking to protect? What are we going to use to actually sort of then basically say these people can see this data or they cannot? Okay, these users, whether or not they're going to see it. And that comes down to, okay, well, we need to essentially tag every row with something that we can then do a true or false on to say, yep, this passes a check, or no, it doesn't pass a check. Which, again, means potentially you're going to have to duplicate data in certain areas or what have you, and you're going to then have that data management overhead built within the application itself. It can be quite painful. Now, it can be very simple. It can be very, very complex. It depends on what you've got to do. I've got a worked example that's on the more simple end of the spectrum. Okay, we'll have a look at it. But fundamentally, the key thing to understand is when we're doing this function, we've passed the data in. Whereas before, if we're building it ourselves, like I mentioned earlier, one of the options we have is we can do functions, we can do views, we can do stored procedures, we can do it all in the app tier. The merit, each sort of option has some merit. That's for certain. But the one thing is where you're writing all of the code that's going to handle all of this, and then you're going to basically make the, when you're doing the queries and such like, you need to remember to call the appropriate functions or call the appropriate security functions, be they in the data tier or be them up in the application tier, to make sure that you're actually going to do that restriction. I've worked with some systems where it was all hand-rolled, if you will, and did some dev work, and then, oops, we forgot to actually put that that function call in that's going to do the row level security for this particular part of the application. So go back and do it all again. Again, you end up going all the way to test and then coming back and doing it again. This is where row level security can help you out. You write the function, you build the data model, and then SQL Server is going to help you not have to remember to go and put that function into every stored procedure or every other function call where you want to do that data restriction. And it's all about having a big sort of tick list. You need to have a plan. If you haven't got a plan, it's going to go wrong. Okay. Now, from what I've said so far, it should be very, very apparent that this is not going to work for ISV apps. You're not going to be able to get SharePoint or anything like that and go, oh, we'll use RowLevel Security and that will solve my problems. Nope. Okay. You need to have control. So if you're doing development in-house, this is where you're going to start looking at potentially being able to make use of this feature. If you're just running third-party off-the-shelf apps, forget about it, I'm afraid. Okay, don't even go there. It's not going to help out. If you're rolling your own reports on top of things, potentially, but then you've got to think about third-party vendor support, contracts, things like that, and whether or not you'll invalidate any of that support, have to rip it all out if you have a problem and then go back to your support vendors. Okay, just be aware of all of those issues. Now, one of the important things to understand here is because we're working with the database schema itself, the traditional security model for SQL Server of logins and users doesn't really apply, okay, because it's data-driven. It's not built into the security model there, okay? So again, when you're looking at developing the applications to try and leverage this capability within the SQL Server engine, we need to think, okay, well, what's my security protocol? Am I authenticating through the application using OAuth and things like that? And I get a token that I can then pass in that then allows me to tag the data and say, okay, well, is this particular user allowed to do it from the application side of things? If you're using Windows authentication, it is possible, but it becomes a little bit more convoluted in the way that you need to start looking and saying, okay, well, who's the user that's coming in from Windows, do the evaluation. And then again, it's all going to fall down potentially if you're coming in through a website that's then sat behind an application pool account that's generic and every connection hits with the same Windows authentication, then that goes out the window. So again, these are all of the considerations you need to think about when it comes to whether or not this is actually going to be a viable option for you. So now that I've finished sort of giving it a bit of a beatdown, we'll think about a potential scenario. So anything where there's a hierarchy involved, where you've got a salesperson and a manager, the salesperson should be able to see all of their data rows essentially in the application. The manager should be able to see all of theirs plus all of those for their minions. Common enough scenario, the hierarchy type thing here that we're looking at. So again, that's what we're going to look at and we're going to work through now. So before we jump in and have a look at a demo, we'll just have a look at the lovely schema that Adventureworks gives us, because Adventureworks is a really nice schema for real-world scenarios because there's a lot of problems with it. So we'll start off with the employee table. What we've got here is basically the list of employees and managers. Now, one of the reasons that I like the Adventureworks schema for this one is because they've got the organization node as a column there in the table itself. Essentially, this is using the hierarchy ID data type, as opposed to doing something like a self-join adjacency list mechanism for building the hierarchies, where you may need to run things like recursive CTEs and such like to try and build them out. Yeah, it's painful. It's not fun. Hierarchy ID can work. Maybe not great at very high sort of scales for number of rows that you're going to be passing in, depending on the functions that you're going to be using with it. But for the purposes of illustrating this demo, it's going to work reasonably well for me. We then have that links out to the salesperson ID. So these are the actual salespeople. So we've got our manager and employee hierarchy, then we actually know who's going to be selling things. Okay. So this is our salesperson. This is where we're essentially going to be looking to do the restriction. So we need to make sure, okay, well, we need to take this salesperson ID and we need to start tagging the data that we want. Now we start looking at the data itself. So we've got a sales order header table and a sales order details table. Now, the relationship that exists here is between salesperson and sales order header. What that means is, in order to restrict things like the rows that we're going to see for the actual granular level of the sales order, we're going to rely on relational integrity here of the sort of primary key, foreign key joins that we're going to be putting in place. If we're going to permit people to see sales order rows so from the sales order details table without having to go through the sales order header table, this is a scenario where we'd have to look at taking the information that's currently held in, say, salesperson ID and actually have to tag all of the rows as well as the header table. Okay, so that's where we're looking at the potential duplication of data within the system there. Okay, obviously you're going to have the primary key, foreign key links in place, but again, all of those bits and bytes add up when you start building out systems that are quite large. Now the sales data is what I refer to as the scope. This is what's going to drive it. Okay, when you understand the scope of what you're looking to try and protect, that puts you in a much stronger position when we go back to what we were speaking about earlier when it comes to security by design. We design it securely from the outset when we understand what we're looking to protect. So we've also got product information out there, which is just ancillary information that's going to add a bit of fluff to the queries that we're going to be querying a bit. So that's the database schema. The way we do this, we have our security classifier function. Okay. Now, build the function in isolation. You can have as many functions within the database as you want, as you need, that type of thing. But only really sort of comes into play when we create our security policy. The policy essentially then links our classifier function to our table object. Okay. So what I can do is I'll put the policy in place. The policy then is active, which means every query that then hits that function is going to fire as well. Okay. That's very, very important. And like I said earlier, if your function is inefficient, then kiss your query performance goodbye, because it's going to run for every single statement. Not nice. Okay. And with that, we're going to start looking at a demo, unless I'll just check in with the guys. Have we got any questions yet? Or
no questions yet.
I've got one.
Uh-oh.
Yeah, sorry. So the security function, because it's a function, can that affect the parallelism of our queries?
I haven't tested it with big scale reporting queries that should go parallel, if I'm all honest with you. The viewpoint I've taken with this is it's more in and around the transactional side of things that I've seen. I'll show you, it might become more apparent why I haven't bothered testing it with large scale reporting queries when we get into the demo, because of one of the things that we have to do with that one. So
just quickly, is the
Yeah, of course.
function that you use to set up row-level security, is that scalar, multi-statement, table value? How does that?
It's inline table value function.
Oh, okay. So it
okay.
shouldn't prevent parallelism out of hand.
Yeah.
I know that it adds a bunch of junk to your query plans. We actually throw a warning for that in Blitz Cache, but
Yeah, exactly. It causes all those problems, but it's also because developers are inherently lazy creatures. Having been one at one point in time, I will use all the features I can to avoid writing code, and that's one of the potential pitfalls of this. So let's fire up Management Studio, and here we go. So not those columns, not those files. I want RowLevel Security file. So here we go. So I'm going to use Adventureworks 2014 on this one. Yeah, I'm running on my local SQL Server 2016 machine here, mainly because given the little blip we had earlier, maybe playing with Azure is not going to be the best thing for me. So first and foremost, because we're building it into our data model, I'm going to create a schema. I'm going to create a schema called security. You don't have to call it security. I'm a simple creature, and for the purpose of the demo and preventing me from being confused, it's called security. And that's going to keep all of my objects, which is going to be functions and policies and things like that in place. Okay, now first things first, the type of application I'm going to simulate for this demo is that we're doing some form of application level authentication. The application is going to know who you are, and we could be coming through a application pool account, anything like that. But essentially, when I ask the application to do something, what it's going to do is open the connection, and the first thing it's going to have to do is tell the database engine, okay, well, this is the data essentially I want to use for the restriction in one form or another. So in order to facilitate that, I'm going to use the session context. Okay, so there's a procedure here called sp-set session context, and essentially it allows you to build something that's akin to a key value pair in the SQL Server session. Now, the key here is going to be employee ID. The value is going to be the app user ID. I'm going to be passing that into a stored procedure that essentially when I open the connection, the first thing the application does is calls this procedure to set this. So it says, I'm this person. Okay, so that the rest of the database session that we're going to be running the query for knows who I am. The important thing that we want to have a look at here as well is this little value here, number 1. Come on, zoom in for me, thank you. That essentially there means, okay, this is going to be read-only. So I can then, if I run this again, I will get an error basically saying, nope, we've set this particular value for this particular key, go away. Okay, just a little bit belt and braces approach to if some bizarre reason someone managed to do some form of injection or what have you, runs this again and says actually they figured out using this, and then say actually we'll switch the value and we'll be all good. No, okay, just helps you protect it for the terms of that session. Okay, so I'm going to create that stored procedure to start with. Okay, now I'm going to create my function. First thing to watch for here is it's schema bound. So, as a few people seem to be quite happy with at the moment, the whole sort of DevOps CI thing. One thing to be aware of here is if I want to make a change to anything, obviously, that I'm referencing this function as part of automated build process or anything like that, it's going to mean that my process becomes essentially offline because I'm going to need to shut my security system down. Okay, this function is basically, I want to make those changes, I need to make this function go away. Prevent the scheme so I can make the changes and then I'll bring it all back. Not a fun scenario, really. Again, this is another one of those sort of little gaps that may exist there in the potential adoption of this one. Anyway, moving on from there. I'm essentially just returning a value to say, yeah, we're going to go for this one or not when it comes to the data we're passing in. Now, the query itself, just for the purposes of this one, because it's a hierarchy ID, essentially what I'm doing is saying, okay, well, find me the employee record that's equal to the person that my application says I am, and then am I a descendant of, essentially the same query again. So let's see. It's essentially saying, this is a fun one to try and explain. Do I have any minions or not? Is basically what this query is looking for. So if I don't have any minions, I'm just going to get my row back. If I have got any particular minions in place or employees or whatever, then I'm going to get my record plus all of theirs, essentially, to allow me to start filtering the information that's coming in from the source table. So I pass in employee ID from the table because that's what the function is going to be parsing. And then I'm doing the lookup based around the content, the session context, where the employee ID, so this is my value. Everything that matches me or my subordinates, that's the values that I want to say approved for being returned. I hate trying to explain that query. Here we go.
Yeah, as soon as you throw his descendant of in anything.
Yeah. Then you've got the parent of, and that's one of the reasons I like employee, I like the hierarchy ID when it comes to hierarchies that are not huge. Well, so when I say huge, I haven't got a huge number of rows that you're evaluating. It just makes it easier rather than doing self-join and then let's recurse and oops, I've run out of stuff, or I'm not going to set max recursion to 0 and then watch my server fall over. Is descendant of just helps abstract away that particular part of the pain. Whether or not there's more efficient ways to do things depends on the type of environment that you're working with. So I've created my function. Then I now need to basically stick it all together with the glue, and that glue is the security policy. So create security policy. Again, it's an object in the database. I'm going to say, okay, here's the filter predicate, which is my function. Pass in the salesperson ID column from this particular table, and we're going to turn it on. Okay, so nice and quick and easy, on it goes. Execute, and done. Right now, we've got it set up and running. Okay, so every query that I hit the sales order header table with is going to then run this function and then do the evaluation and then say, are we going to return any rows or not? Okay, and that's going to go back to the client. So, the reason this is, in my view, a better implementation than writing all of the code by hand is that it's nice and easy to find all of these little objects in your database and then try to tie them all together. Okay, relatively simple. It's all in source control. That makes everybody happy. Security is in the code. It's in source control, so if there's any changes to it, again, you can go back and look at the history. So source control is good. So now that we've got all that set up, let's have a look and see what's going on. Now, before I go in and start querying things, I'm going to do it with some stored procedures. So I'm going to create two. So I'm going to create a stored procedure, which is going to get me some sales order data from the RowLevel Security side of things. And I'm a young, naive developer, and I don't really care about where clauses. You know, I've got plenty of processing power, I've got plenty of CPU, storage is fast. Why do I need to filter my data? Then I've also got a procedure that I'm going to create where I'm a little bit of a more mature developer and I understand the value of a where clause. Okay, so create those two stored procedures for the rest of this demo. Now, what we're going to do now is my Visual Studio side of things my Visual Studio foo is not strong. So rather than go in there and show you some terrible C#, we'll simulate the type of activity here, and it gives me a bit more versatility to play with this. We're going to do it through Management Studio instead. So we're going to simulate it. The application connection opens. The first thing that does when we're going to write the application itself, we basically write a wrapper around this so that when we call that connection, we know we're always going to fire this stored procedure, and I'm going to say I'm employee 274. Which means when I start looking in the content of session context, I'm employee 274. So give me a second. Let's see where Zoom it's gone. So it's suddenly stopped working, which is a pest. Okay, let's try that again. Hey, works now. So I'm employee 274. Okay. Now if I try and do this again, if I want to change that particular value, I want to say, actually, no, I'm going to try and get in and say, I'm going to pretend to be my manager. Like I said earlier, you get an error, okay, because it's set as only read only for that particular session. Then when you change it, is dump the session and then come back again. So now I'm interested in getting some sales data. So my application then goes in and says, actually, go and fetch me that sales data, okay. So off it goes, and there we are, nice and happy. I've got data back. Salesperson ID is 274. Okay. That one doesn't work. There we go. So salesperson ID 274. There we go. I can see that information if we scroll down. We've got 1,987 rows, which is nice. There we go. And all of them are 274, he says. Scrolling all the way down. Nice and easy. Now, that was with the procedure that has no where clause. So it's done all the filtering for us. We're all happy. However, if I come to here, let's include the actual execution plan, shall we? Just a little bit of this. What we're going to do is run the one with the procedure, with the where clause, and one without the where clause. Okay. Off we go. So that one's run. There we go. We've got 2 execution plans back, and 4%. The one with the where clause is potentially considerably cheaper than the one without the where clause. Because the way we need to understand how this is going to work, what it's doing is, even though, let's make that go away. Essentially, come on, let's open the plan in something that's readable. Essentially, what we're doing is saying, okay, we'll do the restriction and then pass that restricted data set into the function. Okay, so that's great. In it goes, done, nice and happy. Okay. Whereas with this one, we're saying, go and grab everything and then feed the whole damn table into the function. That's where it's going to hurt. That's why I'm saying it. That's why I've not really sort of done much in the way of tests with reporting functions, because it depends on the type of thing you're running. I mean, you're going to run a sum for an entire year for whatever. You're going to potentially be feeding a lot of data into this function. And then, obviously, it's an inline table value function, so in theory, it's going to be the more efficient end of the spectrum. But not great. Now, if I just grab this and bring it over, give us something that we can actually read the damn plans in a bit better. Here we go. So, estimated costs. So the one with the where clause, 4.3 versus 95.7. And then we come across here and we say, okay, well, we can see the row estimates now. Where I'm doing the where clause, I've got a stats issue potentially that means I'm shooting low on my estimates. Not great. The actual rows is there versus estimated rows of 134,000, and we're coming in low there. Again, because we've got to go and read all of that data, pass it through into the function itself, again, that's going to drive a bit more I/O. It's going to drive a bit more, let's see, it's essentially going to drive more I/O, more compute, generally make things a little bit more unhappy. And if we look at here as well, you can see here we've got the index scans going on. One of the important things, and as Eric alluded to sort of a few minutes ago, is even though my stored procedure ran and I have no information in there to say go and talk to the employee table, you can see we've got this branch here in the execution plan, okay, going off and talking to employee. That's the function taking place, okay? So even though it's a function, we're still going to see it here actually in the command, in the query execution, which means that we can look for those inefficiencies and we can start to look at maybe doing optimizations for them. So yeah, we've gone in and we've scanned the entire employee table, all nearly 5,000 rows of it. Well, that's on my laptop and my laptop's laughing at it, but what it's not laughing at is coming down and having to sort of go through and say, well, we'll pull in 120,000 rows instead. That's why making it more efficient can make your life a lot easier. You make the query as efficient as you can in the function, but then also good development practice when it comes to writing your queries anyway that you're going to be passing into RowLevel Security, again, can look to improve the overall performance. Don't rely on it to give you that filtering without any pain. Okay. So we can build some indexing. I'm going to skip past that bit. It's just basically getting rid of the actual potential key lookup that's in there. Now, one of the things we want to have a look at, okay, we've got RowLevel Security. Let's go and talk about some statistics, okay? So this is where we can come in and say, actually, I want to create a stats object on my totals due, okay, with full scan. Execute that, if it's done that quite happily. Now, SQL Server 2012, I've got it in my other slide, I forgot to update this one, give me a second. It is. Now, prior to SQL Server 2012, where have we got it? SP1. We required sysadmin, DB owner, DDL admin role permissions to actually do show statistics. 2012 SP1 and above, we only need select permission and access to all of the columns and things like that to be able to view the actual stats objects, which when we think about RowLevel Security and the way the histogram gets built, how do we make sure that we're actually not then sort of able to potentially go and see some rows on values of data that are associated with rows that we're not permitted to see? So I'm going to create a select user here without login, just in the database, and I'm going to switch my execution context. Just makes life a little bit easier for me rather than having to open multiple query windows. And I'm going to grant select on sales order header table and the customer table, just so I can illustrate this. Okay. So I'm going to execute a select user. I'm going to show stats for the customer table, which I've got select statement on, but no RowLevel Security configured. And then I'm going to run this one here, show stats as sales order header table, where I have got RowLevel Security configured on the total due stats object that I just created. Okay. So one of them works, one of them fails. The reason being is that essentially the select user should not have permission on select stats to see potentially values that are associated with rows that they may or may not be allowed to see. Okay, so there are some protections in there about some of the inference attacks, and that's an interesting one to look at. Okay, so that's been a quick run through on RowLevel Security. Have we got any questions in the chat window, guys, before?
Nothing so far.
Awesome.
Let me check WebEx chat real quick. I've just been paying attention to.
That's all right. Just make sure I haven't put
That's
everybody to sleep.
Slack.
Oh.
Nope, nothing in WebEx either, or GoTo. So you are.
No worries.
So takeoff.
Not a problem. In which case, then we're going to go off and.
The question. I'm sorry. The one that just came in. Do we have any special considerations if we're also using partitioning with this? I guess the gist of the question might be like this could mess with partition elimination of some sort.
I don't see how it can, because essentially you're running the base query and then feeding that into so the restriction on the where clause is the one that's going to do the partition elimination, and then that will feed that data into the function, in which case it's going to do the restriction beyond there. So that shouldn't really have any negative impacts on using it in conjunction with partition tables.
Cool.
Not from what I can think and the way the execution plans are showing me the data.
All right. Carry on then, sir.
Cool. So moving on to dynamic data masking. Dynamic data masking is, again, something that we've been trying to do in one form or another for many, many years. And essentially what we want is to be able to prevent certain people from seeing data values that are correct. So we want to basically say, actually, no, you're not allowed to see the salary values, the national sort of security IDs, the social security identifiers, things like that, for the permissions you have within our application, and you are. So that's the sort of thing that we try and do. And again, we can use views. We can roll our own sort of scalar value functions or inline table value functions, that type of thing. We can do it up in the application layer. Many options. There's always many ways to do things. But essentially, it's all about protecting certain specific sensitive values that we have contained within our databases. Now, again, Microsoft have now taken that and they said, okay, well, let's bake this capability into the storage engine. This is bake it into the actual SQL Server engine itself. Say, let's see what we can do to help out. It's going to leverage functions. Now, I say functions. These are not your traditional scalar table value functions, anything like that. They're built-in functions to SQL Server itself, and there's 4 of them, and we have varying levels of control over what we can do with them in order to prevent people from seeing the original data values and the values that should or should not be masked. One important difference between this and the actual RowLevel security implementation is that this does leverage the server security authentication model. Okay, so think logins and users. Okay, that's where it's going to have the permissions, and essentially they're grantable permissions to accounts to say masked or unmasked data. Which one are they going to see? So again, we've got 2 technologies that are fundamentally trying to protect the data, but have been implemented in 2 different ways. I'm guessing 2 different teams kind of worked on it. So we think about some of the data masking itself, and what we're looking for here, and this one's courtesy of XKCD, but essentially what we're looking to try and do is mask that data. It's the data at rest, however, is going to be plain text. Okay, once it's sat there in the database, the DBA is going to be able to see that, which means if you're looking for a solution where you want the DBA to manage the database but not see the data, this is not the solution for you. Go look at Always Encrypted. Okay, go and look at something you've rolled your own. This is not going to help you in that scenario. Okay, so again, when it comes to speaking with the security guys, you're going to turn around and say, well, yeah, we can protect it from the application users and that type of thing, but the DBA can just go in and go, what's the data? Get the data, and off they go. Okay, fun.
Trust position,
DBA, right? DBA is all powerful. Joys of sysadmin. So fundamentally, the way it's going to work is we have a database, we have a user in that database who's going to then ask that database a question. It's going to say, give me the name and national ID numbers or social security numbers if you're in the US of all of the people. And then it's going to get something back. Now, if that user has been configured so that they can only see masked data, then what they're going to get back is a table where the names are not blanked, and then the national ID number where it has been blanked. Okay, and that's what we see here. We see masked data for user 1. Okay, I have the same database. I have a different user this time, user number 2. They're going to ask the same question of the database, but because they've been set up in such a way that they've got permissions to see the unmasked data, then they're going to see everything that's in there. Okay, names and the raw data around the national ID number. So again, thinking about the way we do the authentication with Windows and things like that, that's going to be wonderful. So when it comes to thinking about the potential use cases for this scenario, this is when we think about, okay, well, if I'm letting people do direct queries and they've not got level permissions that allows them to either basically grant themselves the unmasked permission, or they're not sysadmin, DBO, things like that, then okay, we can give people Management Studio access, direct query access, that type of thing, and off we go. Okay, works for things like certain BI reporting solutions where you've got that pass-through authentication of actually if the user who's running the report then passes through to the underlying data source, that's when we get it. Again, however, this is likely to fall down if you've got some intermediary in the data source connection. So for example, if you're running reporting services and you've got a data source configured, and that data source is configured with an identity that it will then connect to the actual database with, then that's going to fall down. Okay, that's when you need to start building in extra logic potentially, which can get very complex in the reporting services, where I've seen this before, where they actually detect who the user is, pass that through as a parameter to the underlying query, and then actually switch the execution context to be able to go and get the data or not. Okay, so again, you end up still having to build in a lot more logic into the application itself from end to end to try and actually sort of make it work the way you want it to in order to handle this single account that's going to be doing the authentication to the database engine. Okay. Not fun. Okay. Again, great potential feature, but again, we're starting to hit a few sort of stumbling blocks here. Now, when we think about those functions that I mentioned when it comes to the actual masks themselves, okay, we got 4, okay. First and foremost is the random function, okay. The random function is really useful for your numeric data types, okay, so you're thinking your integers, your decimals, your money, whatever you're going to be using. Essentially, every time you execute it, you're going to get a different numeric value back at any given point in time, okay. It's not a case of, well, it's got a value of 10 that it's always going to come back with a random number of whatever because it's set a seed value or anything, okay. You ask it, it's going to go, and today you're getting number 22, and now you're getting number 23. One thing to bear in mind is that you have got the ability to set the lower and upper bounds of that range of random numbers that's going to be generated. So there is the potential to really sort of mess it up. So if you say, I've got values 1 to 10 in here, so I'll start at range of random numbers from 11 to 100, because no one's ever going to notice that values 1 to 10 are missing if they execute it over and over and over again, and the human is looking at it is very good at looking for patterns and saying, I've not seen number 9. Okay, then they go and be inquisitive as people are and start saying, okay, well 1 to 10 never shows up. Wonder why that is. Wonder what's there. That's when we start looking for those sorts of things. Okay, so again, also don't just restrict your range to 1 to 10 and, well, I'll just give them a random one back from this pick. Well, it's not going to work necessarily. Just make sure you've got a good size random range that you're going to be giving people so that it's very difficult to start looking for inference around what that data may or may not be when it comes back to the client itself and is displayed to the end user. The next function, default, which is a nice easy one here. It works for pretty much every single data type you've got, and it will provide you with a default value. That default value for string data is going to be 4x's. Funny story, back during the early sort of CTPs, if your string was less than 4x's long, you would get a corresponding x for each of those 1, 2, or 3 characters, up to 4, which was pretty rapidly fixed, thank goodness. So yeah, string data, you're going to get 4x's back. For a date, you're going to get 1st of January 1900. Okay, for numbers, you're going to get zeros, so on and so forth. Okay, basically, it's just wiping that data out. You've got no control about what comes back. It just goes, nope, you're not having anything. Then there's the email function. The email function is great fun. You don't have to apply it to an email string. Okay, you can put it on any string, so you can turn anybody's name into an email address blank, which is great. Not. Okay, just think about how you're going to use them. But essentially what it does is it goes first character, x's at x's.com. Okay, so if you've got .co.uk, .org, and anything like that where you may want your end user to actually have some form of inferred context about the data they're seeing when it comes to email addresses, it's not going to give you that, I'm afraid. It's basically just one size fits all. There's your data gone. Okay, that's what you're getting back into your client when you do the call. And then the last one is partial. Partial's technically the one we have the most control over, whereby we can pick the leading number of characters, we can specify the pad string pattern, and then we can say, okay, on the end I want the last 3 characters, for example. So that's where we've got some control. Again, coming back to the previous thing I was talking about there when it comes to say, okay, well, what about email addresses? Can we use some form of funky sort of string work to say, okay, well, let's find is it a .com, is it a .co.uk, or is it a .org, or anything like that? Nope. Okay, it's discrete value for the start. Here's some padding. Give me that number of characters on the end. Done. Okay, there is no intelligence there. It's pretty dumb. So whether or not it's got a huge amount of value to you will depend, again, on what you're looking at. A good scenario that it may be for would be something like the national ID, where you want to bring the first number and the last 2 and then wipe out everything in the middle. I know that's something you may see on websites for credit card information where you got the sort of first 6, last 4. Don't plan on using dynamic data masking for credit card numbers in your databases because, as I said earlier, the data's in clear text in the database. Storing PAN data in the database in clear text is a big no-no for PCI DSS. So make that one go out of your minds, go and think about kittens playing with balls of yarn, not storing credit card data and masking it with dynamic data masking, because that is bad. Cool. So now we have another demo. Let's go and grab Management Studio again.
Before you get started on that demo, there was one question. It was a little unclear if it was about RLS or dynamic data masking based on when it came in. But
that's right.
Can we restrict data on a column or cell level? Yeah, so I'm still waiting for clarification. I asked for it.
So for RowLevel Security, it's at the row level, not the cell level. So it's not like cell levels. It's not like the cell level security you have in something like analysis services, for example.
Sure.
Anything like that. As for column, yeah, that's where your row levels. That's where your dynamic data masking comes in.
Okay.
And that's what we think about, which is what we're going to look at now. So, dynamic data masking demo. Here we go. So, again, I'm going to use Adventureworks 2014 for this one. Okay, and what I've done is I've created a little function just to help illustrate a point on this one, which is terrible function. And essentially what it's doing is string concatenation for an address, because we should always not do this in the database, but it makes a point. If you need to do this in the application, please. That's where you should be formatting strings and things. So again, I'm going to create a user, this time without a login, again, because I'm just going to switch the execution context because it's easier than breaking this down into 3 or 4 different windows. Okay, so I have my database user. I'm going to grant some permissions to them. So, yep, I'm on the right database. I'm going to grant them permission to see the employee table, the person table, email address, business entity address table, and to select the function. Okay. There we go. So what I do now is if I come down to here, I'm going to switch my execution context over to master user, and I'm going to run this query, which is going to show me the first name, last name, person details, address details. So the formatted address using the function. Okay, nice and happy. So let's run that query. And as you can see here, I have a lovely pile of clear text data from Adventureworks, first name, last name, hire date, sick leave hours, national ID number, email addresses, and a nice clear text address there. So all the lovely sort of sensitive data we may or may not want to share with our employees, depending on the type of role they're doing within the organization. So coming back from there, one thing I will quickly do actually is just copy all of that out and stick it in here, just so that I've got something to go back to, just to prove that certain values are as they should be later if I need to. So, come on. Make sure I have the right context now. So I want to add these masks to my data. This is where it comes in, and we can actually specify them as part of the code. So essentially they're part of the database schema, which is great. It's basically a column property saying add masked and then with whichever of those lovely functions we spoke about earlier. So here I'm going to put a mask on the national ID number on the employee table, and I'm going to use default. I'm going to put another one on the sick leave hours, and I'm going to say random between 1 and 100. Then on the email address, I'm going to use the email function because I can. Okay, so those go off. And again, because that's part of the schema, it's going to be in source control, which means, again, we're getting changes. Boom, we can go back and we can track those nice and easy. So what I'm going to do now is run exactly the same query as my master user again. And this time, as you can see, I've got 4 X's for my national ID number. I've got a blanked out email address here with the first letter and then some X's and some more X's.com. And then I've got the sick leave hours here, which is altered. Now I know that the first one there was 47 earlier. Now it's 21. Okay. And just to prove that if I execute that bit of T-SQL again, there we go. Sick leave hours, just to prove that it is properly random, again is now 18 instead of 20-something that it was a moment ago. So nice and easy. Now, again, okay, well, I want to think about, okay, maybe I want to see the first one and the last 2 of the national ID numbers so that if someone rings in that we can ask that information. So I can just
My
alter
social
the column.
security number for that?
Yeah, if you could, that'd be great.
Yeah,
I'll just go and, that's all right, I'll just check up on Equifax for you. So there we go. We're going to switch it over to partial. So again, it's just an alter column statement, which is nice and easy. So if I come and run this again, now you can see, there we go. We're using partial, national ID number, first one, some padded with X's, and again, the last 2 numbers that we've got coming out of there. Okay.
That is my national ID number, so.
Sweet. So now we want to think about addresses. Addresses, again, sensitive information. Anyone in Europe who is dealing with Data Protection Act or GDPR as it's going to be coming in should be very aware of what is not and what is considered sensitive personal data these days, and anything that allows people to be personally identified is. So let's get rid of the first line of the address and the postcode so that people know rough geography of where someone is rather than being able to go knock on the door. So I'm going to use default again here. And then what I'm going to do is I'm going to come down here and I'm going to execute the statement I executed again a moment ago. Now, let's have a quick look and say, okay, well, the formatted address is now coming just back as 4 X's. What this means is that when we're calling the function and the function's doing the concatenation, what it's doing is getting basically the most restrictive type come back, the most restrictive format. So we see nothing, okay? Not fun. So that throws a spanner in that plan of using a function. Oh, what a pity. I know, I'll use a CTE instead, because a CTE always works. Ooh, okay. Country, region, person. Because all of that was masked by the function, I now need to give more expansive permissions. Not fun. Not a huge fan of expansive permissions for people being able to see everything they should. So we come back here, and then, nope, we're still seeing our little 4 X's. Essentially, the long and short of it is, as soon as you start doing any concatenation against masked columns, you're just going to get a masked value back for the default in this case. Okay, so it's going to be painful. So we want to go away. Let's rewrite it again. Essentially, what we have to do here is then come in and then do a query against it where we're actually pulling back the individual rows. And then, as I said earlier, take it up to the application and do it properly. Okay, in which case you may want to mask it in the application. So if you're going to do it in reporting services, mask it here, take it up, concatenate it using the reporting services. You're doing it in a .NET application, do the query, take it up, concatenate all the stuff together, format it nicely, spit that out to the user. Not going to work here. Okay. Ooh. Zoom back in so people can see this. So just check. Reverted correctly. So that is dynamic data masking is quite easy to put in place. As you can see, you just need to alter the database schema, which again, we're coming back to it. Do we have control over the database schema? Is it ours? Do we own that particular code base? Yes, then it's potentially a candidate for you to use. Is it a third-party ISV application? That's where it gets a bit dicey. Talk nicely to them. Maybe it will work, maybe it won't, depending on what you need to do. Because it's in with the server and database authentication mechanism, in theory, yeah, you'd be able to create a server-level login, map it to a user that has read access to the table, and then you can mask the columns, and then if you've written your own reports or whatever, anything like that, then potentially it can work. But anything that's likely to interfere with the application, your ISV vendor is going to go, not supported. So just bear that in mind.
So with something like dynamic data masking, if it's like a known set of values, how easy is it to unmask data?
We'll get there in a minute.
Okay.
So I'm not going to go into it in
Wasn't
too much
sure on
depth
that one.
because someone has, there's a guy there who's written a very good and comprehensive blog post that goes into how to crack through it. And I will reference that and we'll have a quick look at that a little bit later. Rather than me trying to sort of parrot that information, he tells it better than I can. So I'd say go there. But a couple of things to cover off. You remember we talked about show stats earlier, okay? So if I wanted to execute this as so we've got dynamic data masking in place on the employee table and the national ID number, okay? So because I've got select permissions and I've got access to the columns, I can then come in here and then execute this and say show stats, and then there we go. There's unmasked values in the histogram. Okay. Not fun. However, there is good news. I actually logged a connect item for this, and Microsoft said, thanks, we'll fix it. And they fixed it in they fixed it in Azure SQL database, and they said it'll be fixed in the next version of SQL. Whether or not it will be backported, I don't know. Since the connect item was marked as closed as fixed, there have been 2 cumulative updates for 16 in which that fix has not appeared. So who knows? If we make enough noise, it may get backported. I don't know.
2016 is just so irrelevant at this point. I mean.
Yeah, you know, it's so passé. So,
what year is this?
yeah, it's last year's news. So 2016.
Man, like short shorts.
With SQL Server 2016 SP1CU2, quoting builds at you here, we've now got the DMDB stats histogram DMV. Similar functionality in that it will show you stuff unless you've got Azure SQL database in 2017, in which case it shows you nothing, which is nice. It will execute and just give you a blank table back for the histogram, which is nice. It doesn't tell you that you don't have permissions. It just says, no, nobody here but us chickens.
That was my connect item.
Ah, nice. It makes life a little bit easier, that's for certain, rather than this. One thing as well, if you do want to revert to the earlier permission set where someone has to be a member of sysadmin or the DB owner or DDL admin database roles, trace flag 9485 will revert that behavior for you. So if that makes you a little bit twitchy, there we go. So, done all of that. Data's masked, that's all good. So potentially how do we work around some of these things? This is where I said, and we go back to the start of the session where I was saying, it's important to think about building things up in layers. It's all about understanding complementary technologies and complementary ways of doing things. And this is where I come in back to say, who remembers views and who remembers stored procedures? They're wonderful, wonderful things, and they can help. So if I want to prevent the stats thing or what have you and people seeing extra information, I come in and just build some views, create some stored procedures using basically the traditional way that we would do a lot of this with regards to securing the information behind essentially an abstraction layer. I revoke all of those direct permissions on the underlying objects. I can grant execute on the stored procedure. I'm going to select on the views. And then I can come in and I can execute this as masked user and I can have a look and see what is going on. Here we go. And you can see here we've got the masked data, we've got all of the information, it's all set up. It's nice and relatively secure because people can't get to those underlying tables. So if you are going to use 2016 and you want to play with this and you want to take this technology into production, then again you're able to circumvent it, because if I come back to now try and do show stats, this one here, I don't have the permissions on the underlying table to be able to go and run that stats object. So that worked for 2016. 2017, it becomes a non-issue for us because essentially it's been fixed, and then we go from there. Now,
so just to be clear real quick, you can't just cast the masked portion as a string and have that show up. It'll still be masked. Like if you did substring, whatever in the middle, it wouldn't.
It shouldn't do anymore. There was a point at which it did.
Oops.
I believe that got fixed during the very late stage CTPs.
Okay.
So it's all right. Let's go a little bit off piece. We've got a bit of time. I'm going to write something in the middle of a demo because that's always fun.
Don't do it.
Doing it, he says. Right, so let's take that one. So national ID number. So, ooh. Doesn't want to know. Come on. Right, so that comes from employee details, so it's going to be ED. ED dot. So if I do that, substring, what we're going to do, 0. So, actually, no, let's just do this. Let's just try and cast it as far.
Mariah Varkari.
Because I'm silly. Let's do that. Go away, do this, execute, go all the way to the right. Ooh.
Oh, no use for a name.
It wipes it out. So we get something that's even more restrictive than the type that we were looking for. Okay, which is nice. Okay, now one thing as well that I don't know if anyone's noticed is that I've got a where clause here now. Where clause on postcode.
Uh-oh.
Where clause on that particular zip code.
Dangerous.
Yes, very dangerous. And this is something that Ronan goes into in his blog post, but I'm going to run this. I'm going to, ooh, yay, ooh, postcode. Wonder what's behind that window. Behind wooden door number 1 is that particular value of 98052 because it's an equality predicate, which means I know that all 21 rows have that particular value behind that mask. That sucks. So, yeah, one of the things you can do is you're quite happy to write a where clause and off you go. There's no restriction around that. I did raise a connect item saying, can we look at this? And got closed as by design on Connect, along with a comment of set up SQL audit and you'll find out when people are doing this. And I'll also discover after the case that my data is halfway around the world on somebody else's system. So I'm sorry, Microsoft, but you suck with that response. It took quite a while to compose the right email response there. There was 3 or 4 emails. Okay, God, no, maybe not. Let's delete that one and go back to
smashed keyboard, mouse through a monitor.
Yeah, you know, big face palm. Yeah, that's not, SQL audit is a great little feature, but it's not a security feature. It's a what's happened feature after the case of let's go back and find out where it all went wrong sort of thing, which I'm kind of a bit twitchy about when it comes to data, especially if it's personal sensitive data that we want to really be holding on to and we want to be securing. So back to the slide deck. So I know I had about an hour and a half-ish. We're going to roll in a little bit early on this one, unless people have questions. But essentially, high-level summary, RowLevel Security, you design it into the schema. You have to build it into your application. It's no good for third-party ISVs. It is very customizable, however, which makes life a lot easier. And the engine's actually going to take that function and apply it to everything. So even if you roll, I mean, one of the most common ways of doing this at the moment I have seen is using functions. And people will build up their restrictive data set and then they'll do a cross-apply or what have you, or a join onto the function and say, actually, let's restrict it based around what I'm building here in my tables or whatever. but you've got to remember to write that code yourself. The advantage here is you've still got to do all of that legwork, building that logic into the procedure. You've got to design your data model accordingly, make sure all the data's in place, build it into your application. But Microsoft takes away the fact that you then need to remember to write the damn code to make it happen. Okay, so that's good. Because if you're onboarding new developers and they may not necessarily be completely familiar with your code base, it means you don't get all the way to QA and a bit of UAT testing and then having to go all the way back and saying, can you go and make sure you rewrite your query so that it includes this restriction that we built into the system? People go, oops, sorry. There we go. It's just part and parcel of people becoming more familiar with the code base, and if you've got a code base of several million lines of code, it becomes difficult to manage. Inline table value function, so in theory it's not truly terrible, like a scalar function would be. Dynamic data masking. Use the server and database authentication mechanisms. So again, just think about how it's going to be applied. If you're sat behind a single account that's doing the access to the data tier, that's going to really throw a spanner in the works, and you start having to do a lot more work in there to come up with saying, okay, well, I am this person, which means when I connect as that, I actually want to masquerade as this person in order to see the data that should be masked, and that's what my permission set is. You end up having to build a lot of metadata in around it in order to handle that. It's all masked at individual column level, and it's all part of the code of the database itself, so you've all got it drilled in that schema, which means it's in source control. Happy day. It can be circumvented easily by the DBA because I've got sysadmin permissions, which means then what I can do is I can come back in here and then say, okay, well, actually, if I want to say, well, actually, I want to see that data, so yeah, I'm going to just grant myself unmasked permissions, and there we go. The problem is that there's no granularity to the unmasked functionality either. So it's not like you can say, for this user, I want to grant them the ability to see unmasked data for this object and these columns or anything like that. It's a case of they see nothing or they see everything. So again, that's just another potential gap in that potential framework. So just bear that one in mind. Again, it's yes, no, but the DBA can see everything anyway. But also certain query access patterns will allow you to circumvent that. Okay. Now, that information is run in Airly. Has got a great blog post that goes into that in a lot more depth. I've bit.ly'd the link to his blog so that it's easy for people to see right now rather than seeing the big, long URL. Please take that one away. But if we quickly let's see if I can follow that one. Let's do this. Come on. Is my web browser going to wake up?
One of these days.
Okay, don't.
SQL Server stole all its memories.
Yeah, doesn't surprise me. It's laughing at me. It is actually that my browser is not happy.
What's going on, John? It's like your laptop on Wednesday at the user group.
Yeah, the laptop is, it could do with a little bit of love, I think, and a rebuild. So here we go. Either that or I'm using carrier pigeons to get my web traffic. Anyway, I'll talk about the other ones. Dynamic data masking, Microsoft there have got some interesting documentation that you can use to understand the syntaxes, how to apply it, how to turn it on, how to turn it off, all that sort of stuff. Don't really provide any real context in how to apply it and how to apply it well. The Robert Sheldon's done a blog post as well at a Simple Talk that goes in and sort of gives you an illustration, kind of like the demo I've done today and the session I've done, but in a more sort of concise blog post with instructions. You can go follow this, 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 and this, and go from there. Here's Ronan's blog post. Definitely recommend reading this. He's an MVP, as we can see, but he goes through a whole sort of mechanisms for how to potentially circumvent it. So sets up all the masks and then exposing the mask data step by step. He's got a guide there. Definitely go and check that out. If you are thinking of using this particular technology option, it's well worth reading that. Mainly not so that you can understand how to circumvent it in order to do it, but more to what are the patterns that will allow circumvention, and can I put anything in place that will help make that more difficult. Okay, so when you understand what the vectors are, then it allows you to try and combat them effectively. As I mentioned, connect items, show stats issue, fixed in Azure and 2017. Whether or not that will come back to 16, I don't know. Enhancing unmask to make it more granular. I have actually got that connect item and it's still open. They're thinking about it. Votes help. If you think that this could be useful to you and by having a more granular unmaskability, so you say this database user can see these columns in the table. So I've got a database with table with 10 columns in it, and I've got 8 of them masked, and user 1 can see everything unmasked. User 2 can see 4 of the masked columns, but is allowed to see the actual data in the other ones. Things like that. So having that ability to say, grant unmask to this user for this table, for this column, and this column, and this column. If you think that would be useful functionality, please go and vote on the connect item. The more votes we have, the more chance we have of not getting it closed as by design. And then there's the filtering on masked columns where I got closed as by design and got cranky about it. If you think it needs to be reopened, please leave comments. I think they still get emails when we leave comments on those closed connect items. But I think, again, looking at Ronan's blog and some of the things that he's doing there to try and circumvent it, again, it's potentially a chance for us to try and help Microsoft improve the product. And with that, we're going to roll in and say, there we go, done. If anyone's got any more questions.
No other questions about that stuff. I do have a couple though. Like, so when you were mentioning that, there's access patterns that, still kind of expose data even accidentally. Are there any overall access patterns that aren't a good fit for either of these features, or like who would you recommend them to? Or like what level of...
So I mean, one of the things I'd say is if you've not, when it comes to dynamic data masking, to try and prevent those sort of access patterns where I can put in a postcode that's on a mask column and then see that result set come back and say, well, I know that I used that as an equality predicate and therefore all of those X's are actually this value. It comes back to thinking, okay, if people are going to be doing that sort of querying, you're going to sort of struggle. If it's behind something like reporting services or some form of sort of BI platform where people are not connecting in with interactive query, potentially it might work. So reporting services is where I've looked at using dynamic data masking a couple of times, just simply because historically I've had to do it in the report layer itself, which based around doing Windows lookups about who the Windows user was that was querying the thing and what the report was coming back for. Dynamic data masking is probably the less useful of the two at this point in time, in my view. It's got a lot of potential, but at the moment I don't think it's really there.
So are there any third-party tools or vendor tools out there that would take the place of it or do a better job of it than dynamic data masking?
Not that I've looked into in any real depth. I fall back to my patterns that I know. Rather than spending money, I know I can write some code around that and make it work while saving myself a few dollars, sort of thing. The RowLevel Security, I'm actually evaluating for our product suite because we've got roles and rights-based security in the suite of tools that we have. And at the moment we use functions, and I'm looking at whether or not, obviously this may or may not help, but it's one of those things that I don't think that it's quite really there for ISVs yet because it's 2016 and above. That rules out a large chunk of the old sort of security. There's a SQL Server market out for you if you want to run
90-some-odd percent, I think.
Precisely. So I really like the function, but I mean, we've already got that capability and it works really well the way that we've written it. So at the moment, I don't think there's any real merit in transitioning the code base or anything like that. So we'll stick with what we're doing at the moment because it works quite well. But yeah, I mean, I think it's for anyone developing applications where they wanted to use RowLevel Security, where they may have historically had to use things like nested views, the way that Dynamics used to do it, or pull lots of data up to the application and then filter it there. It may be a candidate for use. But again, it depends on the authentication mechanism for the application, or if you're willing to put the legwork in around building the metadata into the database to handle if you want to use Windows authentication and then handle it that way.
There was a question. Martin wants to know if the demo scripts and stuff are all going to be available anywhere.
Yeah. Brent, do you publish the decks and the demos and stuff? If not, I'll stick them all up on my blog.
I was going to say, we'll put them on your blog, and then that way we'll link from the session to your blog, and people can go grab it. And speaking of which, you should put your blog up there, too. So where do you blog at these days?
blogs.century1.com. So I'm a corporate man.
And there's a lot of bloggers there, too. I mean, there's a lot of sharp people writing blogs over there.
Yeah. So I think we're up to 9 or 10 MVPs now on staff. I lose track.
It's basically you guys in Microsoft hoovering them all up.
Yeah, you know. Yeah, I mean, obviously we've got Aaron, who's a wealth of knowledge and information there. We've got Melissa Connors, who's one of our special projects team here at Central, and she's doing some really, really cool stuff that she'll be blogging about soon. We've got Melissa Coates, we're doing some stuff with Azure at the moment. She's publishing information there as well. Around some of the patterns and practices we're doing. So yeah, there's a wealth of information there. I blog up there as well. I'll put this up there along with all the demo scripts. And let me just quickly grab my, where's it gone? Just jump back and I'll put my, whoa, no, wrong button. I fat fingered it. There we go. That's the one I want. So there we go. I found it. So my contact information, feel free to email me. So if for some bizarre reason that someone thinks of a question tomorrow, just email me, send me a message on Twitter or anything like that. Like I say, I'll get this probably up on the blog over the weekend, and I'll send you the link, Brent, and we'll roll with that.
Cool. Perfect.
So,
perfect.
Cool. But no, thank you very much.
You bet. Nice job, sir. Very good round of virtual applause there.